Hello and welcome back. This is presentation 5.2, Introduction to Random Variables. We want to talk to you about games of chance and expected values. Consider the experiment where you toss two fair dice and you receive an amount of money equal to the sum of the numbers showing on the dice. For example, in the case the red and blue die, the sum there is 5 and 2 are 7. You receive $7. Now we're going to look at all possible outcomes. And as you can see here, a 1-1, sum is 2, so that's how much money you get. And going down, a sum of 3, 1, 2, 2, 1, sum of 4, 5, note there's 4 ways of getting a 5, a 6, a 7. Now feel free to pause the screen at any time and write these out yourself. 9, 10, 11, 12, and now we're going to look at probabilities. Now each of these pairs is equally likely, and there's 36 of them, so the probability of getting a 1 and a 1 or a sum of 2 is 1 in 36. Just simply adding these up and dividing by 36 gives us the probabilities that are coming on the screen now, and the total of those probabilities should be 1, which it is. Now over on the right here we see a distribution of these probabilities. We want to know what the mean or expected value is, and it's right in the center here, and we'll show you it's equal to 7. The mean or expected value, the formula is the summation of the xp of x. Well, we need that column xp of x, which we do so up here. We're taking the x, the 2, times the p of x, straight down the column, and look what we get here. Now feel free to pause the screen to write these out yourself. This is in your workbook. The sum of that xp of x is 7, which means the mean or expected value is 7. Now the standard deviation or measure of the variability is given by this formula. As you can see here, we need an x squared p of x, which we do so up here, and this is just simply your x value squared times your p of x. And again, feel free to pause the screen and calculate these yourself. Now the summation of that column is 54.83, which we put in this position here, minus xp of x squared, which is 7 squared, and that measure of standard deviation is 2.415. As you can see here, this is the variability above the mean, and here comes the boundaries, 4.52 to 9.42 with 68% chance or likelihood. If you had to pay $7.50 to play the game, would you play? Probably not. You're losing 50 cents per game. But if 50 cents would go to charity, then you would probably play this game for charity's sake. Now over here on the right, careful how you write this, because we can expect to win $7 on average per game over the long run. Earnings can vary from the mean of 7 by plus or minus 2.415, 68% of the time. Now we're going to look at rental property, and here we have the case of an individual considering buying a 10-unit rental property in Sylvan Lake, and he wants to look at the likelihood of rental X units, which we have here, 0 through 10, and we see the probabilities that he derives over the past 10 years of records associated with the business. There we have them. Total is 1. Here's the distribution. Now note how it peaks here. We're suggesting that the mean is somewhere over here between 7 and 8. Now looking at the xp of x, multiplying these out, coming down the screen here, the expected value is 6.53, so one can expect to rent 6.53 units on average over the long run. That's per week. The standard deviation, x squared p of x, we need that column up here, and again we're simply multiplying the x by itself by p of x, coming up with this column, and this total x squared p of x is 46.97 minus 6.53 squared, that's 2.08. So that tells you that the variability about the mean of 6.53, 4.45 to 8.61, that's the likelihood of renting this many units per week over the long run. with 68% probability. And so if our profit from rental of 1 unit per week is $1,000, what profit can we expect to generate under this scenario, of course, is $6,530. Well, that concludes this presentation. We ask you to review it once again and go to presentation 5.3.